On the homework assignment, I wanted you to go beyond the simple and think outside of the box for reality. So, we have this production function, and the production function we've been working with on Wednesday was, I'm going to rewrite it here, hopefully you can see it. We said, suppose you have this production process that uses two inputs, labor and capital. Then we said, there are various ways of producing the product. You can increase the amount of labor or reduce the amount of labor. But if you want the same amount, you have to trade off. There's a trade-off. Hopefully the idea of a trade-off makes sense to you. This is it. You don't have a horse ride a cow. So if in America, I call point D, America. You can use a lot of machinery with a small amount of workers and get your 100 tons of rice. In India, they don't have the machinery, but they have lots of people, peasant farmers. They're going to use a labor-intensive approach. Very low-level capital, machinery. Did I mention that capital is machinery? Yes? No? Okay. And lots of workers. The labor-intensive approach, because labor is cheap. Many people with nothing to do, hire them rather than go and buy an expensive machine. The homework question asks, why would India choose to buy an expensive machine when it has all of these unemployed or underemployed workers? That's the outside of the box thinking that we'll come back to. So there are different ways to do the same thing, and different countries will choose different approaches based on the resources they have. Make sense? All right. So we sketched the isoquant. Same quantity. That's what isoquant means. Same quantity. Keep that in mind. So this is my 100 tons of rice using different techniques. And I introduced the idea of the cost line. So let's ask the question. How much does it cost to produce this 100 tons of rice using these different techniques? And the answer, it depends. It depends on the prices for labor and capital. In countries where labor is scarce, the wage rate is high. Let me draw that for you, because I plan to put that on the test as well as another gift question. If you get today's idea, I think you're golden. You're good to go. It might be a little complex. Hopefully not. So what I was trying to do was to sketch two countries and two labor and capital scenarios. Suppose this is the labor market in India, and this is the amount of capital supply in India. Labor supply, India, capital supply, India. In case you're wondering where I'm going, let me say one last time. I'm just trying to express demand and supply analysis. Okay? Simple demand supply analysis. That's where I'm headed for the next couple of minutes. So I'm going to put a demand curve and a supply curve. I'm focused on resource markets, the labor market and the capital market. So I'm going to say, if I add the demand for labor in India, here, LDI, that I will generate a wage rate in India, right here, WI. Supply and demand, give me an equilibrium, that's the wage rate. In the US, I'm going to put the demand in, demand for labor, LDUS, and generate a wage rate, W star. So the first point I want to make is that the wage rate in the US is much higher than the wage rate in India. I can make the statement, or I can show it to you graphically. This is how we would say in the two countries, the wage rates are different, because there's a large amount of labor in India. India has 1.3 billion people. America has 0.3 billion people. So there's 4 times as many people in India as in America. So the supply, if I were to put both of them on the same map, I could put that there and say, this is the US labor supply. This is India's labor supply. It would make sense that in the US, the equilibrium of demand and supply would yield a higher wage. If you try to intuit, why are wages in America much higher than in India? And you say, well, India has lots of people, so the intersection of demand and supply will yield a low wage rate. America has still a lot of people. It's the fourth largest country in the world, population-wise, but it's 1/4 of India's population, higher wage rate. That's a dumbed-down version of explaining why the wage rate in the US is higher than India. There are many other reasons, but that will work to promote the first idea we are focused on. So we're saying that the US has a high wage rate and India has a low wage rate. And the implication is it's because India has a large supply of labor and the US doesn't have as large a supply of labor. Again, oversimplification to make the point. India is capital poor. They don't have a lot of machines. They don't have a lot of machinery. It's a poor country. So I'm going to make the supply of capital in India smaller than this. So let this be the supply of capital in the US. I'm really putting it over here, but I'm trying to show the two of them on the same panel, just to convey the first idea to you. So the demand for capital demand in India. If the demand for capital looks like this, then it shouldn't surprise you that the intersection of demand and supply yields a return to capital. India, that's India. A price for capital that's much higher than if I were to show the same demand and supply for capital in the US, much lower rate for the US. I'm going to put the capital demand in the US here and the equilibrium here. R US, R star. So what is the first idea I'm trying to convey? Capital is cheaper in America than in India, and labor is more expensive in America than in India. You okay with that? I don't have to demonstrate it graphically, but why not? Yes.
So R equals cost of capital.
R is the cost of capital. So on the handout I gave you last time, and I put on Moodle and I used in the video lecture, here's the note you're looking at.
Okay.
Yeah, just hit print on this and write your notes based on this. So the note says, price of labor, quantity of labor plus price of capital, quantity of capital. And it's as an aside, often we call the price of labor the wage rate, and the price of capital is referred to as the rental rate of capital. Most economics textbooks say that. I prefer to keep the PL and PK because it means you don't have to carry, what do you call the return to capital again? Oh, the price of capital. You know that. But in the textbook they'll use R, so why not learn it? In other economics classes they'll say R, the rental rate of capital. But it raises an important question, or makes an important point that you should hear. You might discard it, but I'll say. Technically, and this is specifically addressed to you. Yes, you. I'm trying to answer your question in a long-winded way. The way economics is done, you don't ever own anything. Even if you own it, you treat it as though you are renting it or leasing it. So you might own a car or own a house. When you're doing economic analysis, you have to pretend that you are leasing that car or renting that house. That's how you make good economic decisions. Once you own something, you might say, well, the cost to me in the future is zero. That's the wrong way to make an economic decision. So what you have to say is, assume I'm renting this house from myself, or I'm renting this car from myself. If you own it, you're going to make the wrong decision if you say, I own it, therefore the cost is zero. You have to impute a cost to it every single day if you want to make the best economic decision. For example, you might own a Lamborghini. And you might say, well, I'm going to drive my Lamborghini because I own it. And your neighbor might want to buy it from you. And you have to remind yourself, my neighbor wants to buy it from me. I could sell it to my neighbor and buy a Geo Metro and get to school. So you have to tell yourself, if you use the idea, I own it, therefore the cost in the future is zero, you will make the wrong decision. You have to make the decision as if you were leasing it or renting it. Even the IRS allows you to do that. They allow you to impute a rent. If you're using your house for business, you'll impute a rent to yourself as if you were renting space from yourself. That's the best way to do economics. And that's why we call the price of capital the rental rate of capital. So a business person will own nothing. They'll just own an idea. They will rent labor to pay people per hour or per month or whatever. They'll rent machinery and they would rent the space. When you own it, you're likely to make the wrong decision. When you rent it, you make a good economic decision. So even if you own it, assume that you rent it and pay yourself the rent. Here's another mistake that many business owners make, business entrepreneurs make. You will, and this is a test question on your next test. You are the entrepreneur of this particular operation. That means that you are the genius behind it, you are the manager, you are the CEO, you pay your staff, and then you pay yourself from what's left over. The wrong way to make a decision. You have to pay yourself first. Pay yourself first, that's how you make good decisions. So you say, if I were managing this business for my neighbor or my brother, how much salary would I want? And the reason you have to do that in economics is because many business owners end up taking a loss and cut their own salary in the process, when they could have taken their skill set to another organization and earned a salary, a guaranteed salary. So you work for yourself at a lower wage rate than you could have worked for someone else. The majority of businesses will fail in 5 years. If 10 new businesses open tomorrow, half of them will be gone in 5 years. And part of the reason is that the owners make some decisions that are not good economic decisions. You have to treat everything as if you are renting it or leasing it when you make the decision. Otherwise, you're going to make the wrong decision. Okay, let me get off my soapbox and get back to the idea here. So that's why we call this the rental rate of capital. And you pay yourself first, the wage rate. You don't pay yourself from a residual, you pay yourself first. And you pay for everything. Even if you own it, you put aside money to pay for it, especially for capital, to replace it in the future. So you have to treat everything as if you don't own it. In economics, you own nothing. Even if you own it, you don't own it. If you want to make the best decision, treat it as if you are renting it or leasing it or borrowing it and paying it back to the bank in the case of your bank account. You're borrowing it from yourself. You're saying, okay, I have this $200,000 in the bank. Don't say I'm going to invest it in. No, say I'm going to borrow it from myself and pay myself the interest rate. That's how you make good economic decisions. Every resource must be valued at market value. Otherwise, you're going to make a bad decision. Economists believe that anyway. And that's why the majority of businesses fail, because the owners are so excited about their idea. They keep pouring good money after bad. So you're renting everything. So we're asking the question, how do you make the right decision? So you have to figure out what the prices of the resources are. So my aside basically tried to motivate why the wage rates and the rental rates would be different. As you look at the problem then, you want to sketch, and I'll go directly to the homework. Hopefully you brought your copy with you. You want to sketch the ISO cost line, the cost line. I should tell you that the cost line is also known as ISO cost. So the curve is called an isoquant. The cost line is called an ISO cost. ISO is the Greek word for same. Isoquant tells us that the same quantity is produced using different input combinations. ISO cost says the cost on this line is the same at every point. It's a budget line applied to a firm buying resources or renting resources. So we take our cost equation there. I'm going to rewrite it with K as the subject. So in order to do that, let me bring this down a bit. Down. I'm going to isolate K. So I'm going to bring the C and the PLL together. Bring the PLL over as negative and then divide by PK. So you get K equals C over PK minus PL on PK times L. You will recognize this as the intercept, and you'll recognize this as the slope of the line. The line that says K equals, another variation of that is maybe Y equals mx plus b, intercept and slope. In our case, the slope is going to be negative, and the slope happens to be the ratio of prices. Please pay attention to how this ratio is working. The ratio is the price of labor over the price of capital. If you can't remember which thing goes in the numerator, which goes in the denominator, recognize that it's PLL. So if it's L, the coefficient is going to be PL. Okay? Just to keep things straight in your mind. If I say, what is the ratio of prices? What does it represent? Say, well, it's the price of labor relative to the price of capital. If K is on the vertical axis, the ratio of prices is what is called the relative price of labor. The price of labor relative to the price of capital. So if I say, let the relative price of labor increase, make this number a larger number. Make the slope a steeper slope. Okay? Just be aware that that's the terminology. This is the slope of the cost line. And if this slope becomes steeper, it means that labor is becoming relatively more expensive. You got that? I said relatively. So there are two ideas when I say that labor is becoming relatively more expensive. I'm saying either the numerator is increasing, which will make the number larger, or the denominator is decreasing. Either of those will make this number a larger number. We call it the ratio or relative, the ratio of the prices. In which order do they go? Well, if K is on the vertical axis, the slope is going to be the price of labor relative to the price of capital. So now we need to figure out what number is represented by that slope, and using the graphical analysis, we're going to add this slope to the analysis. The homework problem said, let the price of capital be twice the price of labor. The price of capital is twice the price of labor. So instead of PK, I'm going to write 2PL. Okay? And the PL's cancel, so the slope is going to be 1/2. I need you to see that. The price of labor is half the price of capital. The price of capital, this is the original problem, okay? So let me not create confusion. This is the homework problem. The price of capital is twice the price of labor. That means instead of PK, I can write 2PL. And therefore, I get a slope of 1/2. Let me draw a slope of 1/2 for you. Okay, let me ask the question. I'm going to add a cost line with a negative slope, and the slope is going to be 1/2. How can I figure out the steepness such that it's equal to 1/2? Any offers? Yes, sir.
Plug in one of the coordinates into the slope. So like y equals mx plus b, you already have the slope, so then plug in one coordinate for x. Use one of the coordinates that's given for x and y, and then solve for b, and then you have your equation.
Okay. All right. Any other offers? How can I figure out what slope I'm working with here? Are you thick-skinned?
A little bit, depends.
So if somebody gives a different answer, you will know.
That's
I
the way how
appreciate
I learned that. I'm more of a math person, so that's why.
Excellent. Anyone else with a different opinion? Yes.
Is that something to do with the equilibrium?
Before we get there, I just want the slope. How can you show me a slope of 1/2? Yes, sir. Rise over run. So, I want a slope of 1/2. Keep going. Help him, somebody. You want the slope to be 1/2, the rise over the run to be 1/2. Any ideas?
Over 5 down.
Say it again, please.
It's 5, like the for B would be 5/8.
No, just general. Don't say A or B. 5/8.
5/8. Just I just want to plug in just like a random coordinate from the chart that's on the front page of the. And I just if we could plug that into there to test it out.
Yes, sir.
Up 1 over 2 or down 1.
Bingo. Listen to the man. Rise over run. So if it's a negative slope, down 1, it's 1/2. Down 1 and over 2. Okay? Negative slope. So if I start at 1 here, down 1 over 2, end up here. Pass through those 2 points. That's a slope of negative 1/2. Manifests itself. I know you knew what to do, you just didn't know how to say it. I apologize for stumping you by asking you to prove that this thing is a duck. He said, well, it walks and it quacks, so it's a duck. So what else do you want me to say, Professor? So if I say, show me a slope of 1/2, hopefully you can show it. But if I say, explain to me what a slope of 1/2 looks like, hopefully you know the words. Down 1/2, negative slope. Somebody else, what would you have said? You know when you walked in there and thought you were a policeman? I was thinking, why are the cops coming into the room? Not listening. It's weird when the cop walks into your room. Once I was teaching, and a guy from the CIA walked in and sat in the back. And 3 times he came to my class. 3 consecutive lectures he came and listened to. Then he came up to me and he said, he told me my name, he told me my mother's name, he told me all my life history. I started getting scared. Man, this man knows everything about me. A student of mine asked me to write a recommendation for him to get a job at the CIA. So they did a background check on me. Before they read his recommendation that I wrote for him. So if you want to work for the CIA, please don't ask me to write any letters, because I don't need a background check again. Nowadays they can do it on the internet, but he came in and he told me all my life history so that he could read the letter that I wrote for the student. The student didn't get the job. I'm thinking, that's a lot of effort, man. Anyway, back to the lecture. I got lots of interesting anecdotes. If you have the time, I have the stories. So we have the slope. Listen to me as I perform the magic. If the slope passes through the origin, how much money am I spending? So we have the cost equation. The origin is 0 labor and 0 capital. How much money am I spending? 0. If the slope passes through 4 and 8, 4 on the vertical and 8 on the horizontal. This is a nice test question. And you had this question on your last test as the budget constraint for the hot dogs and the burgers. How much money is being spent here? Well, professor would actually know. How did we come up with 12?
40.
Okay. So you can't really tell me the number unless they tell you the price of one of these things. But you can say that we know you can afford 4 units of capital and 8 units of labor. So if I tell you the price of either one of those, you can tell me how much money is being spent. If I say, for example, the price of labor is 1, then you will say, well, I'm spending $8. Because I can get, for this cost line, I can get 8 units of labor. So if I tell you again, the price of labor is 1, this line represents $8 being spent. I will tell you that the price of capital is 2, which is why I can only afford 4 units of capital. So every cost line represents a certain dollar expenditure. Okay? Here's the more important point. As I move my cost line to the northeast, it represents a higher level of expenditure. So if I show you 3 isoquants lines, and this is a nice test question here. The farther away is the cost line from the origin, finish that sentence.
The more money you're spending.
The more money is being spent. I'm going to move the pens again. Maybe I'll just put 2 here. And I'll ask a really simple question. You know what? I have an even better idea. Same 2 points. So the next page on the Moodle document shows you these 3 cost lines. The idea that line 3 represents a higher expenditure than line 2 or than line 1. But here's the point I need to make sure everyone gets. Okay, I need my first graph again. Yeah, okay, I'll work with this one right here. So I put my pens there again. Can't see that, can you? Here's a technique D that uses 14 units of capital and 1 unit of labor. I call that the technique that America will use. Very capital intensive technique. Here's a technique that maybe Mexico will use. Smaller amount of capital and more labor. What can you tell me about these 2 techniques? Given the slope that I'm working with. The slope is the ratio of the prices of the 2 resources. Remember that. What is the slope? The slope is the price of labor over the price of capital. What can you tell me about point D relative to point B? maybe I didn't ask the question as clearly as I could. Suppose the wage rate in America and Mexico are the same. Let's use Canada, probably a better analogy. The resources used to produce this 100 tons of rice cost the same in Canada and the United States. The United States is using this technique right here, 14 units of capital and 1 unit of labor. And in Canada they're using 5 units of capital and 8 units of labor. Tell me what is demonstrated by the fact that the US is using this technique and Canada is using this technique. They're producing the same quantity, that's what isoquant means, same quantity. What can you tell me about Canada relative to the US, or vice versa? Yes. I'm going to then go first. Save the best for the last.
Well, America's doing it cheaper than Canada would.
The United States is more labor or capital intensive, where Mexico is more labor intensive.
So I'm going to let you repeat what you just said.
It's cheaper for America.
I was gonna say it's more expensive.
It's more expensive. More expensive. America is on the higher cost isoquant. Canada is on the cheaper isoquant. So America is using what we call an inefficient way to produce, and Canada is using the efficient way. Efficiency is defined by when the line kisses the curve. It should not cross the curve, it should kiss the curve, barely touch it. And since as I move the pen up with that slope, I'm raising the amount I'm spending, I want to minimize the cost of doing this thing. I want to spend the least amount to get my 100 tons of rice. So I want to pull this thing down. And when it barely touches, the lower I can get that line, the cheaper is my cost. What needs to happen then is we need to get rid of this technique, because this technique is costing too much, and switch to this technique, a more labor-intensive way of doing things. Sometimes we use a capital-intensive approach because that's all we have. And another country might have a labor-intensive technique, and we say, you know what, we should import what they have. If we have the prices given by the slope of this pen, the price of labor relative to the price of capital, if that's the ratio of the factors' prices, then this is the equilibrium. If we are producing here, we're not at equilibrium. The line should kiss the curve. It should not cross the curve. And therefore, this is called inefficient. You're spending too much. You can spend this much, whatever number this turns out to be. This represents a higher cost. So I'll put that question on your test. I'll show you a graph where the cost line crosses the curve. And it might be a true-false statement, or it might be a fill-in-the-blanks question. What can you tell me about that? It's inefficient. Efficiency and equilibrium are represented when the line tangentially touches the curve. Now, the slope of the line is given by the ratio of the prices for the goods, the resources, sorry. And they are what they are. Labor and capital, cost, XYZ, or PDQ. Therefore, I need to figure, with those factor prices, where do I have this equilibrium, where the line costs, the cost line, sorry, touches the isoquant. Not crosses, touches. If it crosses, it means I'm spending more than I need to. I'm going to pull this down until it barely touches, and pulling it down means I'm spending less and less and less, because when it passes through 0, 0, I'm not buying anything, I'm spending 0. So this is a cost line of 0, cost line of 1, 2, 3, 4, 10, 20, 30, 40. The farther out I go, the more I'm spending. The closer in I come, the less I'm spending. If you want to produce 100 tons of rice, you want to spend more or you want to spend less. Find the technique that costs you the least. So B would be the equilibrium at this particular slope. C is the equilibrium at that ratio of prices. And D is the equilibrium at that ratio of prices. I need for someone to generalize what I just said, so let me try again. I'll start the sentence and have you finish the sentence. America is producing rice efficiently at point D. America is in equilibrium in producing rice at point D. India is in equilibrium at point A. What can you tell me about America
they're spending money on capital efficiently, and India's spending money on labor efficiently.
Okay. Does anybody want to edit that statement? Another way of saying that. Pretend he hasn't said anything. America is operating at equilibrium at point D, and India is operating at equilibrium at point A. What can you tell me? What can be said? If it's equilibrium, it means that the prices are the right prices for the country. So this is America's price line, that's India's price line. What can you tell me? Look at those two price lines. What's the difference between them? The slope. What does the slope tell us? The slope is steeper in the US. The ratio. The ratio, what's the ratio? PL on PK. That's the ratio. So finish. You're almost all around the bases.
So, America either has higher labor
This is great.
or lower
So labor is more expensive in America, or
capital.
capital is cheaper in America, or some combination of the two. The slope of the line is a higher number or steeper slope in America than in India. It means that either the price of labor is more expensive, makes sense, or capital is cheaper, or a combination of the two. So if I tell you that both countries are doing the best they can, they're operating at different techniques, if I say they're doing the best they can and they're in equilibrium, then what is left to be said? If they're in equilibrium, it must mean that the ratio of prices in America is higher than the ratio of prices in India. That ratio, with L on the horizontal axis, is the price of labor to the price of capital. It means that labor is more expensive in America. And labor is cheaper in India. Or alternatively, that capital is cheaper in America, capital is more expensive in India. Or maybe combination. The relative price of labor, the ratio of the prices, is higher in America than in India. If you got that, more power to you. I want you to get it. The general question is, why do different countries use different techniques? Why is India using a labor-intensive technique and America using a capital-intensive technique? It's not because we have the supplies. It could be. Sorry? Half of what you're saying is not reaching the front of the room. A little louder.
Using whatever they're selling, whatever American Indian is selling, if it's to each other or one another, America maybe only needing to use so much of their resources for this X amount compared to however many labor intensive, however large the labor intensive for it required to use the same amount of American.
I have a friend who owns, I think I told you, the McDonald's in Rochester Hills. The stores, he is the proprietor for the stores in Rochester Hills. And he says sometimes he goes in and he fixes procedure. I have to go in and fix procedure. They're not doing it right. I have to tell them, okay, this is how you do it. So there's a lot of fixing procedure that needs to occur in your comment. Firstly, please, I hope you're thick-skinned about this. If the countries are operating and both are producing the product, it's rare that they will be trading the product with each other. If they're both producing the same thing, then one will export it to the other. They both will export it to each other. Make sense?
Yeah.
So,
It's not sure.
I'm sorry?
Could it be that it's short only with one product? Or are you saying that there's possibilities that there's more than one product is sold?
Right. So when I show you this curve, the isoquant, you're producing the same thing using different techniques. Different ways of doing the same thing. So I said each country is producing rice. So it would not be the case that America is exporting rice to India and India is exporting rice to America. It would be that they're like two separate worlds and they don't even trade. So I think because you mentioned selling to each other is why I wanted to fix that, because I think that that's an easy fix. So what I would prefer to say, I appreciate your answer, because again, we all benefit from fixing procedure. So these two countries are like two islands. They're unaware of each other. And in America, we have a technology-rich way of producing, and in India they have a labor-intensive way of producing. The reason they might produce with a labor-intensive technique is because they have a lot of labor. Labor is cheap. On the other hand, America is producing with a capital-intensive technique because capital is cheap, or labor is expensive. So that's the first idea. But once the two discover each other, we will not continue to have two techniques. One technique will dominate. And we will ask the question, which is cheaper? And whoever can produce it cheaper, that country will be the one to produce it. This is called common sense economics. So if I know you can do something better than I can do it, I'm going to let you do it. I'm going to buy it from you and save some money. Take the time I save and the resources I save and produce more of the thing that you want that I can do better. It's called opportunity cost. So I'm glad the idea of trade came up in the question, but very likely if I say there are two different ratios of prices, you would say these countries are unaware of each other, they're not trading. Because one of the things that trade does is that it equalizes the prices. There's one price that we'll obtain with trade. There's a lot more that needs to be said with that. I mean, I can open a whole floodgate of entire fields in equnomics with that idea. But for now, if you see two different sets of prices, it's safe to assume the countries are not trading with each other. Because trade will equalize the price of the goods. And as we go further in the semester, I will say that trade also equalizes the price of the resources. Let me go ahead and expound on that for a minute, then I'll back off and come back to it later. It is more likely that a machine is sold for the same price in India as in America. Very likely one manufactures John Deere tractor. And John Deere is selling this. If you want it in India, this is the American price. You pay the American price. Or a Lamborghini produced in Italy. One price all over the world. Not an Italian price, an American price, and an Indian price. This is the price. You call up Lamborghini, they tell you what the price to make the car for you. They custom build each car. It's going to be the same price. They don't care where you are. The shipping costs may make it more expensive in America than in India and Italy, but anyway, assume one price. So once you have the idea of trade, that one price idea should come into play. Trade theory says that when trade occurs and the prices come to the same level, the prices for the resources will also come to the same level. I'm going to back off after I say this because it's an idea that will anger some people. And trade theory says, since the prices for the resources must come to the same level once trade is occurring, it means that the wage rate in the US, let me see if I can show that graph I drew earlier. Can't find it. The wage rate in the US and the wage rate in India will come to the same level. Like water finding its own level, they're going to come to the same level. And American unions cringe at the idea that India with this low wage rate and America with this high wage rate will one day have the same wage rate. Because what the unions in America see is this. They don't see this, they see this. And that's why unions are against free trade. Unions make money from the membership. If the membership loses wages or loses jobs, the union gets smaller. Unions oppose free trade because American unions think that foreign cheap labor is going to cause wages in America to go down in the future. And it's better to stop and tell all the presidents don't allow free trade or don't let our jobs go elsewhere because they can anticipate that the wage rate in America is going to fall. And no one goes to college expect to make a low wage. Here's another by the way. This will come back later in the semester too. In the 1990s, we were scared by something called the Y2K problem. The thought was that in the year 2000, since most computers and electronics with computers in them were designed in the 20th century, that the computers did not know how to roll over from 1999 to 2000. And the 99 will become 100, and the computers will have this idea that they should go to 19100 rather than 2000. So we got very scared, and we thought that this was a problem that needed to be fixed. So American companies said, we need computer engineers to come in and fix these problems. America didn't have enough computer engineers to fix the problems. So American firms asked the US Congress to grant permission for engineers from India to come in and work on solving the Y2K bug. Congress did not act fast enough to allow enough Indian engineers to come in to solve the problems. And some smart Indians who were already in America said, you know what? We can send this work to India. And that started what is called the outsourcing of IT, information technology jobs, to India. India is now the capital of IT that's been outsourced. Bangalore, India, the city of Bangalore. But those jobs could have stayed here in America for college grads to have. Those jobs are now in India. Associated with that is an entire field where if you call for technology help, invariably the person on the other end of the line helping you fix your computer is in India. They might say, hi, this is John from Chicago, but it's Rajiv from Bangalore. In part of the training, they take on American accents, they take on American names, they claim an American city, because they want to make it as seamless as possible. If you believe the person is in America, you're going to trust the work they're doing more than if you think the person's far away. That was part of the bias in the system. Let me get back to the main point here. The wage rate in India is going to rise, because lots of good jobs have gone to India. Will the wage rate in the US fall? Hopefully not. But theories suggest that the wage rates are going to come to the same level. The same way you sell the computer or the tractor for the same price, if you trade a good and it brings one price for the product all globally, and the resources cost the same, that trade will cause wage rates to equalize. And as I said, this creates a lot of fear in the American Union. So here I'm showing you two different ratios for resources. And if I say that the ratio of prices, the factor prices are the same, and America is operating at point D, your conclusion is America is operating inefficiently. It's not a point of tangency, so it's an inefficient allocation. If I show you this, and I say both countries are operating at equilibrium, you will say, well, the wage rate in America is clearly higher, and it's because this product is not traded between the two countries. But some smart person will look at this and say, oh, the wage rates are different, the returns are different, there's a possibility to trade this product. And whoever can produce it cheaper will promote the product to the other country. And this is a no-trade situation. We'll end up with a traded situation in the future. That's just like beyond where we need to be right now. But I'm just saying, when you see this graph, look at it like this, with two different price lines, you say, that can't sustain itself in the long run. You wouldn't have different prices in the long run, because trade will cause prices to equalize. And if trade causes the price of the good to equalize in the two countries, it will also cause the price of the resources to equalize. That's a theory that we have in international trade. So I'm just giving you that to say there's a lot more coming as you anticipate this. Let's get back to the actual homework question then, just to make sure you've done it correctly. So here's the question. I think we've done enough background work on this. So the question said that the price, same data we've used for the in-class assessment, the price of capital is twice the price of labor. Which means that price of capital to price of labor, the ratio is 1/2. We talked about having that slope at 1/2. So I set the slope at 1/2, which you said is 1 down and 2 across. So all of these green lines here are slopes of 1/2. And what I need to do is to push the cost line out till it kisses the isoquant. And the first point at which it touches, that is the equilibrium. That's the cheapest way to produce this particular quantity of goods. Okay? The equilibrium is when the cost line touches the isoquant. And if I show you, as I said I will, that, you will say there's a cheaper way. The cheaper way involves bringing the cost line down to a point of tangency, but it also involves letting go of producing using this technique and switching to this technique. Got it? This is the wrong technique given the prices. It's the right technique if the prices for the factors exhibit that ratio. But if the factor prices are like that, B is the best or cheapest technique. Now there are different ways to answer the question, and the method I just proposed is probably not the one you chose. The one you chose is probably the one we did in class, and what that says is that wherever you see PK, you can write 2PL. So I'm going to rewrite this equation then, and I'm going to write 2PL here, in which case I'm going to write PL into 2K plus L. I need for you to see that. If the price of capital is twice as high as the price of labor, where I have PK, I can write 2PL, and I factor the PL out from both of these terms, I get PL into 2K plus L. Are you with me? You did it for homework. So take the capital number, multiply by 2, and add the labor number, and that's how we calculate the cost. It will be PL times that, but since all of them will have PL in them, it doesn't really matter. The PL is just a scaling up. So let's calculate that. So we're going to multiply it by 2 here. 2 times that, plus this. 2K plus L. 4 plus 15 is 19. 10 plus 8 is 18. 18 plus something is greater than 18. 28. So you can quickly dismiss some of these calculations because you've risen above the lowest number. Once you spot this 18 here, don't even bother to calculate these two. You understand what I'm saying? You can write the numbers out. Say, if I say on the hand, I said, show you're working. If you're really slick, you'll say, hey, we already found a low number. The others are going to be higher. I give you extra credit for being smart. It's not fair to give extra credit for being smart. You should get extra credit for effort. But anyway, I'm saying that don't do the extra calculations. Once you spot a low number, don't even bother with the other numbers. And the second problem, I said make it 3 times as high. So we have 6 plus 15 is 21. 15 plus 8, already higher than 15 plus 6, so I stop. That's it right there. And because you know that the isoquant is shaped like that, and the ratio of prices, if you found that D is cheapest, if you're doing it graphically using this analysis, D is cheapest, and then C, B is, this is the new ratio of prices, 3. So every line that's farther away costs more. If you were doing the approach of let me kiss the curve with the line, you stop at the first one. As soon as you touch the line, as soon as the line touches the curve, you stop. I need for you to get that idea. You don't have to do all the calculations. If I give you the graphical analysis, you say, I need to put my pen at a slope of 3. Well, negative 3. A negative slope of 3. So you figure out a slope of 3. You go with 12, and 12 and 4. So just to avoid having to draw many lines, I'll go up 12 and 4. 12 and, what did I say? 12 and 4, right? That's the steepness of the line. That's the slope of 3. You figure, okay, well, use that slope, pass through the point D. And if when you pass through point D, you can still see C, S-E-E-C, letter C. To the right, you know that D is cheaper. I'm saying that you need to help yourself to solve the problem efficiently, as fast as you can. And sometimes, if you have graph paper, you can look at it. You don't have to do the calculations ever. If I say which one is cheapest, then you can figure out a slope of 3. You say, I found the slope of 3, D is cheapest. Okay? So think on these things, and I'm going to stop there. Well, let me not stop there. Let me just get you up to where I took the last class so to make sure that I don't have to repeat anything. So here are 2 other things I said to the other class. I will ask you about the properties of isoquants and the properties of isocost lines. So in the true-false questions, I will say, isoquants do this, and you'll say true or false. And isocost lines do this, and you'll say, again, true or false. So let me tell you what those properties are for an isoquant. The first property is that 2 isoquant lines never cross. 2 isoquant lines never cross. So in your textbook under isoquants, it will say here are 4 properties of isoquants. I want for you to look at those properties. The first one is that 2 isoquants can't cross. Because if every isoquant represents a level of output, and the 2 of them cross, they will say that the same quantity of resources can produce 2 different levels of output. Now, these are not like important things, but they're common sense things. If this is the 200 unit output level. This is the 100 unit output level. You can't have 10 units of capital and labor producing 100 and 200 at the same time. The two isoquants never cross. The farther away is the curve from the origin, the higher is the level of output. That should make sense. You're using more resources, you get more output. So the higher the curve, the higher the output level. Two isoquants can't cross. They're negatively sloped. Intuitive, right? They're negatively sloped, and the slope changes. That's the fourth property. Let me do one small experiment on the negative slope, which is intuitive, and I'll be done. So if I say, verify that the slope has to be negative, you say, well, but by contradiction, proof by contradiction, it can't be positive. For example, if I had 10 units of capital and 10 units of labor, suppose the isoquant curve were positively sloped. It's called a proof by contradiction. 10 units of capital and labor give me 100 units of output. 20 units of capital and 20 units of labor can't give me the same 100 units of output. So it can't be positive. So I can't use more resources for both and get the same level of output. It can't be a positive, it has to be negative. So that's one proof. The other is the idea that if you use more of one resource, you should get more output. So if you're here, 10 and 10, and you use 20 units of labor, you should be on a higher indifference curve. You have more resources, so you should get more output. So the higher curve represents more output. The four things are intertwined, but if someone asks you to describe the isoquant, these are like four things that you should say. I might come back to this on Monday. Sorry, you have a long time. I might come back to this, but be prepared for the properties of isoquants. Look in your textbook for that section. It's like 5 lines long. Be on your test. Have a good break.